Okay, this is the last video for the substitution rule, and this is dealing with the area of regions. And as soon as you see a question that says find the area of the region bounded by the graph and the x-axis, you know that you're talking integration. So, and somehow it's going to involve the substitution rules because it's in the in the substitution rule section. So we're going to set up the area function, and if I'm looking for the area of the region bounded by the graph f of x and the x-axis, we're looking at an integral of f of x minus the x-axis. The x-axis is simply y equals 0. So the integral would be, or the integrand would be f of x minus y equals 0, which is 0. Right, the region bounded by the top. This is your top function, and that's your bottom. Okay, you could graph this and see what you're looking at. The other thing that it tells you, that the information that the problem gives you, is the limits of integration. You want to look between x equals 0 and the square root of pi. So this is simply, excuse me, this is simply an integral that you need to solve. So looking at this, hopefully you see that you've got a substitution problem here. You've got a power of 2 as an argument to sign, and of course one less than that is just plain old x. So let u equal x squared, du is equal to 2x dx. I'm going to make the necessary substitutions. Hopefully you can jump now to omitting the step with solving for dx. If you can't, solve for dx. You're going to make your substitutions. And we're solving a definite integral. And I'm going to substitute in for u. And then du over 2x. Alright. Just going to continue this for a while until you guys totally get a hand of it. I'm going to pull out the constant. And this becomes just the integral of sine of u du. And hopefully you remember that the sine of u, the integral of sine of u du, the antiderivative, is just minus cosine u. But remember, we have to put in another step here to change the limits of integration. Right, because we have the integrand in terms of u, but these limits of integration are in terms of x. So we got a mix here. We've got u's and x's, so we've got to change one of them. Okay, I don't care which way you go. I'm going to do a substitution all in terms of u. So I'm going to change the limits of integration. So I'm going to put the lower limit into, right, that whatever you let u equal, I'm going to put the limits of integration into that. So it's 0 squared, square root of pi squared, sine of u du. Now everything's in terms of u. So we can just go ahead and evaluate this. Right, square of a square root is just cancel out, and everything is in terms of u. So we're good to go, all in terms of u. This gives you a little bit more practice with definite integrals. So take the antiderivative and evaluate it. so this becomes 1/2. Bracket it minus cosine of u evaluated between 0 and pi. And this is equal to 1/2 minus cosine of pi minus cosine of 0. Keep your sign straight here. All right, it's very important to keep your sign straight. Remember the fundamental theorem of calculus, okay, is f of b minus f of a, right, where a and b are the upper and lower limits. Okay, so evaluating that, hopefully you remember your trig rules, and this becomes, right, negative the cosine of pi is a minus 1, and minus cosine of 0 is minus 1. Hopefully we keep our sign straight, and you end up with 1/2 times 2, and the answer here is just simply 1.